1.2, graphs of equations. All right. What is a graph? What is a graph? Yeah. Okay, Cartesian planes in two-dimensional space that we're going to be working with in this year. I don't think we go to 3. No, we're going to be in 2 dimensions all year. But what's a graph?
Isn't it a way to display information or data?
Good. I think we're getting somewhere. Yeah, that's really good. All right. Could be lines, could be curves, could be lines and curves. But what does a graph represent? What does a graph represent?
Solutions.
A solution set. That's all it is. Okay? Algebraically, you got like an equation or something. But a graph, all it is a sketched out solution set. That's what a graph is. That's why we do it. All right? So, a graph of an equation is a set of solutions. That's all it is. All right? So now we have these points. We have a point 2, 13, and a point -1, -3. And I need to figure out if it's on the graph. And if it's on the graph, it is a what? Starts with an S. Solution. It's a solution. So all we're going to do is we're going to substitute this in. All right? So we're going to substitute this in. So what's my y value of that? 13 is equal to 10 times what? 2 minus 7. So order of operation, 10 times 2 is 20. 20 minus 7 we'll call what? 13. Is 13 equal to 13? Yes. Yes, it is. What did we just prove?
That's in the line. That's on the line passes through that point.
That point is a solution to that graph. Did we graph the whole thing? No, we didn't graph anything yet. All right, -1, -3. So now I'm going to substitute that in. So now I end up having, what's my y value? -3 is equal to 10 times -1 minus 7. 10 times -1 is? -10 minus 7. And we end up with what? Is -17 equal to -3? Not in this lifetime. So, what do we know? This is not a solution. All right. Now, real quick, I'm going to keep this recording for my little virtual people. We are not going to say plug in. Okay? A plug-in is actually something that goes into a voided outlet. Like this, if you're going to plug in the pencil sharpener, it's actually a voided outlet. This is called substitution. All right? So when you substitute out -3 for y, you switch them. Okay? Does anybody play sports? Eric, you play sports? Eric, you're a pitcher, right? Mm-hmm. Eric, if you're pitching and you hit 3 batters in a row, what's Mr. Nipper going to do?
Substitute me out.
He's going to substitute you out, which means you did what? You switched. You switched with one another. That's what this is mathematically too. All right? It is not a plug-in because there's no voided outlet here. Okay? So now we're going to graph by plotting points. We're rarely going to do this. So we're going to graph by plotting points. We're going to rarely do plotting points by graphing, but just to make sure we know what to do, here we go. So we're going to have a sketch a graph of x squared minus 2. First of all, what kind of graph is x squared? Yeah, it's a what? It's a parabola. All right, it's a parabola. All right, so if we substitute in -2 as my x value, what's my y value? 2. So my ordered pair is -2, -2, 2. And then if I substitute in -1, what's my y value, Mary? -1. So then, if I substitute in 0, what's my y value, Maddie? -2. And then if I substitute in 1, what's my y value? Max, do you know?
0.
If I substitute in 1. 1 squared is? 1 minus 2 is? Good job. All right. So then I substitute in 2. What do I get, Juan? I get 2. All right. And then if I substitute in 3, what do I get? I get 7. All right. So we have a parabola that looks like that. All right. Now we're going to find intercepts. What is an intercept?
It's when a line goes to another line.
Okay, it's going to cross another line, but what specific line is it going to cross? The what? The y-axis or the x-axis. Now, we talked about this yesterday, which is very important. What's another name for an x-axis, Braden? Elijah, what's another name for an x-axis? Y equals 0. What's another name for an x-axis? Or a y-axis, I mean. X equals 0. So guess how we find an x and a y-intercept? We substitute in 0 for the other one. Because if we're going to find an x-intercept, guess what I substitute in for y? 0. Exactly. All right. So to find an x-intercept, I'm going to substitute in 0 for y. So now I end up having 0 is equal to x cubed minus 4x. Now, we know how to factor. What can I factor out of this bad boy?
X.
I can factor out an x. And what am I left with? X squared minus 4. Can it keep it? Can I still f it up? Yeah, what can we f it up to? X times x minus 2, and then x plus 2. So now I'm going to use the zero product property, and so I end up getting x is equal to 0, x is equal to 2, and x equals negative 2. That is not sufficient, because guess what all three of those things are? Those are lines. Those are lines. Those are not intercepts. So guess what we need to make them? We make them ordered pairs. All right? So now I end up having 0, 0, 2, 0, and negative 2, 0. And those are my x-intercepts. All right? Because if they cross the x-axis, y equals what? 0. Because that's what the x-axis is. All right, now we're going to find y-intercepts. So how do I find y-intercepts? Substitute 0 in for x. So now I end up having y is equal to 0 cubed minus 4 times 0. So y equals 0. And again, that's not sufficient because y equals 0 is a what? A line. So I need to make it an ordered pair. So I end up with 0, 0. Why is that x 0? Why is the x 0? Because that's what a y-axis is. A y-axis is x equals 0. All right? All right. So, symmetry. Has anybody ever looked in the mirror? Some people do it more than others. Braden just wakes up like that. All right? So, if you look in the mirror and you wave with your right hand, what does it look like?
Waving with the left.
Looks like you're waving with your left, isn't it? All right? And so that's what a symmetry is. It's basically a reflection over each other. So for that one, an x-axis symmetry, it reflects basically, it reflects over the x-axis. A y-axis symmetry, guess what? It reflects over the y-axis. An origin symmetry, it actually kind of has like a 180 degree kind of going on. Remember those rotations you did in geometry? Maybe a little bit, maybe not. All right. So this is how we do it for algebraic tests for symmetry. If we graph an equation that's symmetric to the x-axis, we replace y with negative y. All right. Another way to think of it is f of x, your original, is equal to negative f of x, or y is equal to negative y. When that occurs, you have x-axis symmetry. Just like when you found an intercept, what did you change? You changed the other one. All right? So if an x-axis symmetry, who am I changing? the y again. I make the negative y, and I need to see if it's equivalent to just the y. This next one, if I'm doing a y-axis symmetry, I replace x with negative x. In other words, f of x is equal to f of negative x. All right. And then the third one, if you have origin symmetry, you change both and you see if they're equivalent. In other words, f of x is equal to, or negative f of x is equal to f of negative x. Or you could say f of x is equal to negative f of negative x. Either way you want to think of it, they're both origin symmetry. So here's one. I have y equals 2x cubed, and I need to figure out if it's symmetric to the x, the y axes, or origin symmetry. So let's just test the x-axis first. Let's go in order. So if I need to test for x-axis symmetry, what do I change? I change it to negative y. So now I end up having negative y is equal to 2 times x cubed. Now, I want to solve for y. I want to see if it looks like the original. So what do we need to do to solve for y? Divide by what? Divide by a negative 1. So when I divide by a negative 1, I end up with y equals negative 2 x cubed. Now, I can't go any further. Is this the same as that?
No.
It's not. They're not equivalent. So does it have an x-axis symmetry? No, it does not have x-axis symmetry. So now let's test for y-axis symmetry. If I do y-axis symmetry, I substitute what in? I change what? The x. The x becomes negative x. So now I have y equals 2 times negative x cubed. When I raise a negative to an odd power, what happens to that negative? Do what? It's negative, right? Negative 1 to an odd power is still negative. So this is the same thing as y equals negative 2x cubed. Is this the same as the original? No, it's not. So it doesn't have y-axis symmetry. Now we're going to test for origin symmetry. And I'll tell you a cheat code after this. To test for origin symmetry, we need to change what? Both of them. We need to change both of them. So I not only have a negative y is equal to 2 times negative x cubed. So this is still negative y is equal to, what happens here again? The negative gets to? It gets to come out, right? So now I have a negative 2x cubed. Well, if they're both negative, I need to solve for y. So I need to divide by what? Negative 1. So we're going to star fox that. All right, so choom choom. So now I end up with y equals 2x cubed. Is that the same as the original? Yes. So it has origin symmetry. Now, are you ready for a cheat code?
But if it's origin symmetry, doesn't mean it's that like third type of symmetrical graph where it's the curve.
It's kind of like it's kind of that way. It's actually more of a rotation. It changes both x and y. They kind of go whoop like that. So I think we're on the same track.
So if it's origin, it means it's doing that?
Yeah, it's a rotation.
Okay, cool.
Yeah. So you never have to do an origin symmetry. Because if you do x-axis and y-axis symmetry correctly, these will be the same if it has origin symmetry. Does that make sense? If I do x-axis symmetry, I change the y, right? If I do y-axis symmetry, I change the x. If these two are the same, that's basically what we did here. We changed both the y and the x. Are you following me? So if you do these first two right, you actually never have to do this one. You just look at what you got before. Could you do this? Yes, but we can work smarter, not harder. All right? All right, try this next one. For x-axis symmetry. So how do we test for x-axis symmetry? We change the y. So now I have x minus negative y, quantity squared, is equal to 1. Now, what happens when we raise a negative to an even power? It becomes positive, exactly. So this is y, or x, minus y squared is equal to 1. Is this the same as my original?
Yes.
Yes. So what do we know?
It's symmetry.
It's symmetric about the x-axis. Now, we don't really need to keep going, but we're going to just do it on this one. Let's test for y-axis symmetry. So, for y-axis symmetry, we change the what? The x to negative x. So now we end up having negative x minus y squared is equal to 1. I can't really go much further than that. But are they the same as the original? No, it's not the same as the original. So does it have y-axis? No. And then let's use our cheat codes. Let's test for origin symmetry. Do I actually ever have to do that one? No, I never really have to do that one. I can just check to see if the y-axis and the x-axis are the same. Are they the same? No. So we don't have origin symmetry. All right? Circle! So the standard form in a circle is when you have a center, h and k. All right, the center, h and k. And we have the quantity, x minus h squared, plus the quantity, y minus k squared, is equal to r squared. And r is your radius. And our center is h and k. Read for us.
On the bottom?
Yeah.
It says find the equation of a circle. The point 3, 4 lies on the circle whose all lines on the circle whose center is at negative 1, 2. Write the standard form of the equation of the circle.
All right, fantastic. So this point, 3, 4, lies on the circle. What does that mean? What's a graph? If it lies on the circle, what does that mean?
One of the solutions.
It's a solution. So 3, 4 is a solution to my equation. That's a solution point. That's what that is. And then I have the center, negative 1, 2. So that gives me my what?
There's your midpoint and
My h and my
k.
k. Actually, it really is a midpoint. It's totally true. All right, very good. All right, so I have a solution point and I have my center h and k. What am I missing? I'm missing my radius. That's what I need to find. All right. So, what should we find? We should find the distance between the center and the solution point. So how do we use the distance formula? Square root of the difference of my x's is what? 3 to negative 1. What is the difference of my x's? 4. So I have 4 squared plus 4 to 2. My difference of my y's is what? 2. So I end up with square root of 20. So my radius is square root 20. Now, I personally would leave it that way. Leave your calculator out of it. Fine, just like that. So now, how do I find the equation of a circle? I need my h and my k. Do I have those?
Yeah.
And do I have my radius now?
Yeah.
Now, guess what? I can just substitute them in. So then I end up having the quantity of x minus what? X minus negative 1 squared, and then plus the quantity of y minus 2
My bad,
squared is equal to the square root of 20 squared. And then let's just make that a little prettier. X minus a negative is really what? X plus 1 squared. And then plus y minus 2 squared is equal to 20. And then there's your homework. That's a creepy clown. Enjoy.